Hello students, welcome to Maths Online Academy by Sandhya. Myself Sandhya. I am very happy to welcome you all to this complete class 10th mathematics course. In this video series, I am going to teach the complete class 10th mathematics syllabus in a very easy and simple way. Even if you feel mathematics is difficult, don't worry. I will explain every concept step by step in a clear and easy method. So every student can understand easily, interestingly and confidently. In this course, I will cover all important chapters, textbook questions, board exam questions and shortcuts and easy tricks to get good marks in mathematics. So stay connected with me, learn regularly, practice daily. Let's make mathematics easy and interesting together. Let's start our math journey. In class 10th mathematics syllabus, total 14 chapters. Those names are real numbers, sets, polynomials, pair of linear equations, quadratic equations, progressions, coordinate geometry, similar triangles, tangents and secants, mensurations, trigonometry, applications of trigonometry, probability, statistics. Today I am going to teach you the very important concept, division algorithm, in chapter number 1, real numbers. I am not going to teach directly formulas. Let's discuss some interesting puzzle about bees and flowers. Let's start. First, we will solve an interesting puzzle about bees and flowers. And by the end of this video, we'll understand what is dividend, what is divisor, what is quotient, what is remainder, and the famous formula A equal to BQ plus R, and R has some condition 0 less than or equal to R less than B. But wait, if it looks difficult now, but end of this video, it will become very easy. Students, numbers are everywhere in our daily life. From the moment we wake up, we check the time, we count the money, and we measure the height and weight. So, numbers are in our daily life. Now, let us look at a very interesting puzzle. In this puzzle, we have 5 conditions. About the bees and flowers puzzle, if bees sit on 2 flowers, 1 bee is left. If bees sit on 3 flowers, 2 bees are left over. If bees sit on 4 flowers, 3 are left over. If bees sit on 5 flowers, 1, 2, 3, 4, 5, nothing is left over. So 0. No one is left over. So, and the last condition is the total number of bees are less than or equal to 50. Let's solve. What is the condition? What is the question is here means how many bees are there? That is the question. So, let's assume total number of bees equal to X. And in this 4th condition, if bees are sit on 5 flowers, nothing is left. So, X equal to 5 flowers. 5 flowers are shaded. 5 into that bees, let's we take A, 5A plus 0. And here same, X equal to how many flowers? 4. Here divisor is 4. 4 into we don't know how many bees are sitting in flowers. So this is also B. And remaining one is 3. In this condition, same, x equal to, here divisor is 3. 3 into, how many bees? We don't know. So here C plus remainder is 2. And here also same, 2 D plus 1. Here we don't know A, B, C, D. For example, bees are sit on 5 flowers. We don't know how many bees are sat on there. Here also same. That's why we are assuming those bees are A, here bees are B, here are C, here is D. And by this condition, we can get one clarity. Remainder is 0. Here less than or equal to 50. Means those number of bees may be 5 factors. So therefore let bees may be 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50. Based on fourth condition and fifth condition, we can guess. By this condition that number of bees are 5 factors. And those are less than 50 or equal to 50. So maybe chances the number of bees equal to from 5 to 50. Okay. And I will rub this one. From this is the first one, this is second, and this is third, and this is fourth, and fifth one is what? Fifth one is x less than or equal to 50. Okay? By fourth and fifth conditions, we are getting little bit clarity. Those bees are maybe 5 to 50. And from first condition, x equal to 2d plus 1. 2d plus 1 means it's clearly mentioning that is odd number. From this, we can choose odd numbers. What are odd numbers from 5 to 50? 5 and 10 is even. So 5, 15, 25, 35 and 45. From first condition, we filtered from 1 to 50, 5 to 50 to 5 to 45. And that number is compulsory odd number. First condition is clearly mentioning plus 1. Plus 1 means it will become compulsory odd number. And next, from second condition, x equal to 3c plus 2. So it is divisible by 3. It is divisible by 3. It is divisible by 3 means here are 2. Remainder will come 2. So it's satisfying. 15 by 3 means 3 5s are here. Remainder is 0. So this is wrong. 25 by 3. 3 8s are 24. Here remainder is 1. So it's not satisfying. And next 35, 3 1s are 3 and remainder is 2. So this is satisfying. 5 and 35 are satisfying. And next 45, 3 1s are 3 5s are. Here remainder is 0. On condition of 2, these two only satisfying. So finally 5 and 35 are the numbers to maybe chances to total number of bees 5 and 35. And next to third condition, the remainder is 3 divisible by 4. Here remainder is 1, so this is not satisfying. Divisible by 4. Here remainder is 3. Sorry, this is satisfying. On the basis, on condition of third condition, the final answer is 35. So let's check. So from one condition to fifth condition, we are filtering all numbers from 5 to 50 to become 5 to 45. And second condition, it become 5 and 35. And third condition, the final number of bees are total number of bees equal to 35. So we get the final answer is 35. Let's verify all. Total number of bees are 35. The final answer is 35. So for 35, see here, 35 divisible by 2, 1 is 1, 7. Here remainder is 1. So this is satisfied. For 35, here divisor is 3. 3 ones are 3 ones are here, and remainder is 2. This one also satisfied. And 35 by 4. Here remainder is 3. So this one also satisfied. 35, 5. 7 remainder is 0. This one also satisfied. So final answer is 35. All conditions are satisfied. So the total number of bees are 35, and that one also less than 50. So this is the answer. Here 35 equal to 2. Here something D plus 1. This is the dividend. This is divisor, na? Divisor means that flower is sharing. Number of number of flowers are there? That is this one. So divising, sharing. Those flowers are sharing the bees. That is the divisor. This is the quotient. This is the remainder. So the famous formula, what? A equal to BQ plus R, and 0 less than or equal to R less than B. Here see, here A is the 35 in first condition, B is the 2, Q we find out, plus R is the 1. So 0 less than or equal to R less than, what is the B here? 2. R means here 1, na? So less than R may be 0, 1, but not equal to 2 or less than 2. Here 35 by 2. 7. Q equal to 17 here. division algorithm formula. The famous division algorithm formula A equal to BQ plus R, and R has the condition 0 less than or equal to R less than B. In division algorithm formula, clearly we discuss, for example, see one example, 35 is divided by 2, and this is dividend, this is divisor, quotient, and this is the remainder. This is remainder. So based on that, let's try. Let's see one example, this one here. Dividend equal to divisor into quotient plus remainder. Let's convert into formula for two integers. For two integers a comma b, for two integers a comma b, dividend and divisor respectively. There exist two whole numbers. Two whole numbers Q and R, quotient and remainder respectively. Quotient and respectively. See, based on this dividend, let's see. A dividend is A, B is divisor. So A equal to B. Quotient is here Q and R respectively, into Q plus R. A equal to BQ plus R, and here 0 less than or equal to R less than B. Here see, remainder is 1. Here R can become 0 or 1, not less than B. Here B is 2, na? So maybe remainders become 0, 1, not 2. This may be 0 or 1 in this condition, not compulsory. So the famous division algorithm formula is A equal to BQ plus R, and R has the condition 0 less than or equal to B. Remember, in this division algorithm formula, three things are important. First one is remainder is always less than what? Remainder is always less than quotient. Remainder is always less than, what is this? Divisor. Remainder is always less than divisor. And the famous formula, A equal to BQ plus R. By using this formula, we solved so many problems in chapter 1.1, exercise 1.1. And the condition is 0 less than or equal to R less than B. Roughly we have to know what is the, if you know divisor and dividend, but what is the condition for R means it should be 0 less than or equal to R less than divisor. Remainder is always less than the divisor. For example, divisor is 2. Maybe chances R will become 0 or 1 but not equal to 2. You concentrate on these 3 points. For final exams, they ask what is the condition for R? What is the division algorithm formula? This condition. Thank you for watching. In next class, we will continue exercise 1.1. Based on this formula, we do the problems. Thank you for watching. If you feel this is useful to you, please share, subscribe and stay tuned with us.